Hey Pre-Calc, welcome back to Unit 3. We are going to be doing some solving this week, solving with all of these things that we've learned. Today we're going to solve equations involving logarithms. Equations. All right. 3.6. So if you want to kind of take a minute and review some of the log properties, some of them are helpful. All right, so we're going to start with what is a logarithm? Like a reminder. So when I have something in called exponential form, looks like this. I've got a base raised to the x equals some answer, right? This is my exponential form. And the reason that logarithms were such a useful tool when it was discovered is we had really no way to find that exponent except for guess and check. 2 raised to the what is 8. You just had to guess and know it. So the logarithm is really helpful because you are solving for the x. Like the answer is the exponent. Base is still the base. So this says log base b of a is x. This is the logarithm form. Two little reminders about logarithms. If you see a log with nothing, no base written, that's 10. Similar to the square root doesn't have a 2 on it, but it's a 2. And if you see log base e, e is the natural log, ln, the natural log. It has its own button. Very exciting. And on the calculator, if you ever click the log button, that's log base 10. And if you ever click the ln button, that's log base e. Those are still just logarithms, but they're whatever. All right. And so just a little example. Let's say I had 9 raised to the 2 equals 81. What that would look like as a logarithm, right? I would have log base 9, because the base, the number being raised to the exponent is 9, of 81, of the answer, will equal the exponent. So just to kind of keep those straight. All right, let's get into it then. If you've got a problem with a logarithm, just one logarithm in it, for example, log of 10 x to the third equals 3. Now, right away, reminder, this is really log base 10, right? But if there's just one log in your problem, rewrite it as an exponential form. Because in this case, I want the A is where the X is. I want that to be alone. So I'm going to rewrite this in exponential form. So this is really 10 raised to the third, right? Because the base is 10. The exponent is the answer, equals x to the third. And in this case, 10 to the third equals what to the third? It's 10. It's 10 is 10. You want to be looking for what's the same on both sides, and then you can kind of just eliminate it. Whatever's the same on both sides, you can eliminate it. X is 10. I really recommend, as you're getting started with these questions, check your work. So plug this back in, double check. Is log base 10 of 10 to the third really 3? Yes. And that is a log property. Again, if you would like to review all the log properties, go for it. Go for it. Sometimes they're very helpful. Another example, log base 4 of 4x minus 3 equals 3. Okay, again, if there's only one log in my problem, I'm going to just rewrite it as an exponential, especially if the x is in the a part. So if we rewrite this one, the base is 4, the answer is 3, the exponent is 3, equals the a, 4x minus 3. And then this is a very simple problem. Solve for x. 4 to the third is 64. Add 3 both sides. And divide by 4 both sides. I'd leave that as 67 fourths or 16.75. Plug it in and check. Plug it in and check anytime you want to. 67.5 times 4 minus 3 is 64. And 4 raised to the third is 64. So it's correct. You win. Let's see one with a natural log in here. So let's say I have 6 times the natural log of x minus 6 plus 8 equals 9. I'm going to switch colors so this doesn't blend in. Now I only have one log in this problem, but it's not alone. So I want it to kind of look like this, where it's like log base b of a equals something. The log is kind of isolated. So we got to get rid of that 8, and we got to get rid of the 6. So let's first subtract 8 to both sides, and then divide by 6 both sides. So the natural log of x minus 6 equals 1/6. Now that your log is isolated, and a reminder that the natural log is just log base e, okay? And if you were to rewrite it like that, log base e of x minus 6 is 1/6. Rewrite this as an exponential equation. So e raised to the 1/6 is x minus 6. Add 6 to both sides. And then I'm just going to type this whole thing in. Most calculators, your phone included, will have like an E button. Mine is blue right here. So I'm going to click second ln. And that's going to give me E raised to the 1/6 plus 6. So it's about 7.2 roughly. Okay. Now what to do if there's 2 logarithms? Okay. So I say I have log of a to the 2 equals log of negative 2a plus 3. Oof, barely fit. Okay. If you have a logarithm like this where there's 1 on each side, to cancel it out, I'm going to use this property where if I take my base number, which in this case is 10, right? Because there's nothing there. And I raise both sides of the equation to 10. That will cancel out the logarithm. It looks like this. So 10 raised to all of this junk. And what I do to one side, I must do to the other. 10 raised to all of this stuff. What that will do is cancel the log on this side. Cancel the log on this side because the bases match. And then you're going to be left with a squared equals negative 2a plus 3. Now, how to solve what's left? There's 2 a's. This is quadratic. So let's get everything on the same side of the equal sign. a squared plus 2a minus 3 equals 0. Can you factor this? Or quadratic formula? Let's think. Are there anything that can multiply to negative 3 and add to 2? Yes. Positive 3 and negative 1. These two multiply to negative 3 and they add to positive 2. So my solutions would be negative 3 and 1. Now, I was actually very curious about these answers. I wanted to take a look at it. So I did graph this one. I want to show you. It turned out really cool. Anytime you want to graph something, just get it equal to 0. So when I was typing this graph, let's see, I want you to be able to see both. There we go. I just took my original part of the equation and subtracted the other, so the whole thing's equal to 0. And look at this graph. What? Wild. It's a wild graph. But where are the solutions? Well, they're at negative 3 and 1. So like we're totally correct. Those two, it's exactly where it crosses the x-axis. But that's also a great way to check if you're correct at the end. Just set your whole equation, get it equal to 0. We just moved, and I changed these to x's from a's. I just moved this part to the other side of the equal sign and then graphed it. And those are my solutions. All right, last one. Let's say I have the natural log, ln, of negative 5x minus 5 minus the natural log of 9 equals 4. Okay, so I've got two natural logs. They're on the same side of the equal sign. If I move one over, this 4 is going to get in the way. So I need to use a property of exponents, or I mean logarithms. When I have the same logarithm with the same base, I can connect them in some way. If there's subtraction in between, I can rewrite this as a division. So I'm going to kind of squish these two things together. The natural log of negative 5x minus 5 divided by 9. If this were a plus, it would be times 9. So just kind of reminder of that logarithm property equals 4. Now, rewrite this in exponential form. Reminder that this is just log base e. So I'm going to go e to the 4th equals this whole thing. Negative 5x minus 5 all over 9. And then this is just, it's a little bit of a messy, but it's a simple solve for x problem. So I'm going to multiply both sides by 9. I'm going to add 5 both sides. I want to type this all in at once so I don't round it too many times. Equals negative 5x. And then the last step will be divide both sides by negative 5. When I did type this in, I like to type it all in one if you can. Anytime you've got an e, it's just going to be a nice long decimal point. All right, 9 times e raised to the 4 plus 5 divided by negative 5. So x is right about negative 99.3. And just to check that, like if you're not 100% confident about your answer, how to check it, how to plug it back in, I will just type this whole thing, and instead of x, let's sub in 99.3. So the natural log of negative 5 times 99.3 minus 5. What? the natural log of -5 times -99.3 minus 5. There we go. Minus the natural log of 9 equals right about 4. And because 99.3 was rounded, this is rounded to 4 as well.